Hey everybody, and welcome to our lesson about special angle pairs. There's a lot of good information coming your way, so make sure you are ready to go. Alright, our first special angle pair are what we call adjacent angles. Alright, and adjacent angles are two coplanar angles with a common side and a common vertex. They have no common interior points. So if you look over to the right, I've got a couple examples of adjacent angles. Oops. And as you can see, adjacent angles are right next to each other. That's what that word adjacent means. And they share this common side. So angles 1 and 2 are adjacent because they share this common side. And angles 3 and 4 are adjacent because they share this common side. So they're right next to each other. Now, vertical angles are two angles whose sides are opposite rays. All right, so if I look over here, angles 1 and 2, and I'm going to highlight these, 1 and 2 are vertical angles. Okay, they are right across from each other. And angles 3 and 4, they are vertical angles. Again, you can see they are right across from one another. Boom, boom. So angles that are across from one another, they are vertical angles. All right. Complementary angles. Complementary angles are angles whose sum are 90 degrees. Okay, let's go ahead and put this word angles in here. Complementary angles are two angles whose measures have a sum of 90 degrees. They might tell each other, hey, you're all right. I love those math jokes. Our next set are supplementary angles. All right, and supplementary angles are two angles whose sums add up to 180 degrees. All right, so over here you've got a picture of some supplementary angles. Okay, and if I added an angle over here, this angle B would have to add up to 180 with angle C. All right, let's put this into practice a little bit. But first, we're going to talk about probably the most important special angle pair, and that's what's called a linear pair. Okay, and a linear pair is a pair of adjacent angles, meaning those angles have to be sharing a common side, whose non-common sides are opposite rays. So in other words, it's two angles that form a line with their non-common sides. The angles of a linear pair, we got to kind of squeeze this in here. All right, the angles of a linear pair form a straight angle, like I mentioned. And if the two angles form a linear pair, then they are supplementary. Okay, meaning their measures add up to be 180 degrees. Okay, so again, a linear pair is two angles that form a line with their non-common sides, and they are supplementary. Okay, let's practice a little bit. These questions ask you to name two pairs of angles. I'm going to name one, and you are going to name the other. Okay, so if I have to name two angles that are vertical, the first that I see would be angle 1 and angle 3. Okay, so I'm going to go ahead and put those down there. Angle 1 and angle 3. Name two pairs of adjacent angles. All right, so let's clear this out. Adjacent angles, one example of adjacent angles could be 1 and 5. Angles 1 and 5 could be adjacent angles. Okay, and I'll let you guys find a pair of supplementary angles. So go ahead and take a moment and name one more set of vertical angles and one more set of adjacent angles, and then try to find some supplementary angles in there. Pause the video and then check your answers. All right, so another set of vertical angles, and this one is not quite as easy to see, I don't think. But if you look closely, angle 2 paired with angles 4 and 5 together would be vertical angles. So this is kind of hard to see. It's angles 2 and angle 4 plus angle 5. Together, they give you vertical angles. Okay? Now, two pairs of adjacent angles, you had to give me another one. Another example of some adjacent angles could be, say, angles 4 and angle 3. Okay? And then some supplementary angles, those angles that add up to be 180, and in this case they are also a linear pair. Look down here, angles 2 and 3. Alright, now we've got a good base down here, fundamentals of those angle pairs. Let's start to solve some problems. So in number 5, I've told you that two angles are complementary. Remember, that means they add up to be 90 degrees. Hey, you're all right. The measure of the larger is 6 less than 3 times the measure of the smaller. Okay, so let's take what we know. We know there's two angles that add up to equal 90 degrees. Okay, there's a smaller angle. I don't know what it is. We'll call it x. All right. Now the larger angle is 6 less than 3 times the smaller. So since we called the smaller angle x, this other angle has to be 3 times and 6 smaller. Okay, so my larger angle is actually 3x minus 6. Now I've got an equation that I can solve. X plus 3x is 4x minus 6, and that's now equal to 90. Okay, you're going to have to add 6 to both sides, so 4x equals 96. All right, then go ahead and divide both sides by 4. So x now equals 24. Awesome. Now, I've got to find the measure of both angles. So one angle is 24. Okay, that was x. Now I've got to do 3 times 24 minus 6. Or I could also just do 90 minus 24 since I know they're going to be complementary. So let's just go ahead and do 90 minus 24. Our other angle is 66. All right, you guys try part B. Pause the video and then check your answer. Okay, for part B, two angles are supplementary, so I know they're going to equal 180. The measure of the larger is 54 more than 8 times the smaller, so let's go ahead and call the smaller x, and the larger is going to be 8x plus 54. Now, adding my like terms, that's 9x. I'm going to go ahead and subtract 54 from both sides, so 180 minus 54 would be 126. And then you got to divide both sides by 9 to find out the measure of my smaller angle x. So 126 divided by 9 is 14. Okay, so 14 is the measure of your smaller angle, which means your larger angle has to be 180 minus 14. All right, which is 166. Cool. Moving on. In this next example, we're going to look a little bit at the angle addition, the idea of angle addition, that when I have adjacent angles, I can add their measures together to make a larger angle. So if I'm told that AOB, so that's this angle down here, AOB is 4x minus 1, and BOC, that's the angle adjacent to it, is 2x plus 15. And then I'm also told that AOC, those two angles put together, is 8x plus 8. Okay, I can set up an equation now that says 4x minus 1 plus 2x plus 15. That's got to be equal to the measure of AOC, 8x plus 8. Okay, now I've got this nice equation that we can solve. So I combine my like terms. I get 6x plus 14 is now equal to 8x plus 8. All right. Let's go ahead and subtract 6x from both sides. We get 2x over here. All right, I'll subtract 8. We get 6. Divide both sides by 2. So x now equals 3. Okay, we were just asked to solve for x, so we don't need to go any further with that. All right, now it's your turn. Go ahead and try number 8. Pause the video and then check your answer. All right, for question number 8, we are given that COD, okay, that's COD, this larger angle over here is 8x plus 13, and then BOC is 3x minus 10, and then BOD, the large angle, is 12x minus 6. So again, I can set up an equation, 8x plus 13 plus 3x minus 10 equals 12x minus 6. Okay, now we're solving. So 11x plus 3 is equal to 12x minus 6. By using my inverse operations, I get x is equal to 9. All right, hang in there with me. We're on to our last concept, and that's this idea of an angle bisector. Okay, an angle bisector is a ray that splits an angle exactly in half. Okay, it divides an angle into two congruent parts. So in this picture, this ray AY is the bisector of angle XAZ. It splits this angle into two equal parts. Okay, that's the idea of an angle bisector. Now, in the questions we have here, I'm told that ray QS bisects angle PQR. So let's go ahead and draw a picture over here. All right, we'll say this is PQR. All right, now I've got this ray QS that is bisecting it. All right, now we're told to solve for x. So PQS, that's this angle right here, is 3x, and SQR is 5x minus 20. Since QS is the bisector, I now know that 3x is equal to 5x minus 20. And we can go ahead and solve for x. So I subtract 5x and I get negative 2x equals negative 20. So that means that x equals 10. Okay, we are also asked to find PQR. So if I can plug in x, or 10 for x, I know that this is 30. So that means that PQR has to equal 60. Okay, your last task for this video is to go ahead and try number 18. All right, folks, we're back. Time to check your answer. So we know that PQS was 2x plus 1, and now RQS is 4x minus 15. All right, they have to be this angle. They have to be the same since there's the bisector. All right, so we'll go ahead and solve. 2x equals 16, and x equals 8. All right, that means that one of your angles is now 17. So the measure of angle PQR has to be 34. All right, folks, hope you learned a lot. That was a lot of information to take in. Now your goal is to complete pages 20 through 25. You're going to have to actually flip back to the last section to look at the beginning of the problem set. Complete pages 20 to 25, and then you're taking Math Excel Quiz 7.4. That's all for now.